factoring, one was solving equations. We've done that. The other one, number 2, is simplifying rational expressions. And there are many other applications, but this is the second one we have to look at. First of all, let's define a rational expression. What is a rational expression? RE. A rational expression is a ratio of two polynomials. A ratio of two polynomials. Examples. 1 over 2x, 1 over x minus 1, x plus 2 over x minus 3. These are all rational expressions. They don't have to have x in the numerator, but they have to have x in the denominator. What is not a rational expression, for example, 1/2 x. This is linear. This is not rational. It doesn't have x in the denominator. You can say, but I see a fraction, but this is a numerical fraction. So this is like a simple number times x. So if a ratio does not have x in the denominator, that is not considered a rational expression. Is this okay? Any questions so far? Okay. The next step is, before we get to simplifying, is talk about something called when a rational expression is undefined. When is it undefined? Okay. Well, here's an example. 1 over 2x minus 3 is undefined when 2x minus 3 equals 0. I move 3 and divide by 2, x equals 3/2. So I will say this expression is undefined when the denominator is 0, meaning, and that will happen when x is 3/2. Is this okay? Can anyone give us when is this expression undefined? When x equals
2.
When x equals 2. So basically I should write x minus 2 does not equal 0, so x cannot equal 2. But these are two different questions. So if I'm asked when is this expression undefined, I'll say when x is 2. If I'm asked what is the restriction on x, then I will say x minus 2 cannot equal 0, so x cannot equal 2. You can say that there is a fine line between the two. Correct. Correct. If you're asking me what is the number that makes this expression undefined, I will say 2. If you're asking me what is the restriction that you will write on x, I will say x minus 2 cannot equal 0, x cannot equal 2. Any questions? Any questions? Okay, What if I have the following expression, rational expression, x over x minus 2, and I'm asking you to evaluate it for x equals 0, x equals 4, x equals 2. What would you do? What is the idea here? What do we need to do?
You just plug those numbers in for x?
Absolutely. Absolutely. When x is 0, I have 0 over 0 minus 2. When x is 4, I have 4 over 4 minus 2. And when x is 2, I have 2 over 2 minus 2. Exactly. I plug them in. Absolutely. Good. So, what now? What do we get in the first 0 over 0 minus 2? What is the answer?
Undefined?
0 over 0 minus 2. This is 0 divided by negative 2, which is?
0?
Yes. Perfect. The second one. Perfect. What about the second one?
2?
Yes. 4 divided by 4 minus 2. Please do not simplify terms. 4 divided by 2 is indeed 2. Perfect. What about the last one?
That one's undefined.
Yes.
Can't be on the bottom.
Exactly. That is undefined because it's 2 over 0. Excellent. Very good. That's how we evaluate. Do we need more examples on evaluating? Please say yes or no. Okay, I want to caution you on something. Any number divided by 0, as we know, is called undefined. However, 0 divided by 0 is not undefined. However, your book considers this undefined. It's incorrect. But I want to caution you. This is an indeterminate case. When you get to a certain problem, and please select both as undefined. However, that's incorrect. Any number but 0. This is not 0, the numerator here. Not 0. Not 0. This is called undefined, but this is not called undefined. However, your book considers it undefined. So I just want to caution you about that. Okay, so let's suppose we have 4x divided by x squared minus 9. And the question here is, find x that makes 4x over x squared minus 9 to be undefined. What do we need to do first? Anybody? What do we need to do first? This is all based on the previous module. This is not something entirely new. Anybody, please? In order to determine the x values for which this expression is undefined, we need to do what first?
Factor out.
Yes, the denominator. There's nothing I can do to the top. That's 4x, it's 4x. But the denominator, yes. What do we need to do to the denominator? This part is on the test today. Just that part.
What part?
Factoring the denominator without the word denominator. So,
Oh, it's perfect square.
of course, the difference of perfect squares. Very good. How do I factor it?
X minus 3, x plus 3.
That's it. So now you will give me what x cannot be, or what x creates an undefined situation, which is
Negative 3 or 3.
exactly. So you either answer x cannot be plus or minus 3, or you answer x equals plus or minus 3 makes or make 4x over x squared minus 9 undefined. 3 and negative 3 change this expression into an undefined expression. Okay, I think we got the idea. Now I would like to continue. Simplify rational expressions. Simplify rational expressions. So let's start. Here's the first one. X minus 9 over 9 minus x. You can say, oh, simplify 9 with 9, x with x. Is that allowed? I want to simplify x with x, 9 with 9, and it's done. Is that a yes or a no? Yes or no, please.
No.
No, because we cannot simplify terms. Excellent, thank you. Good. The numerator is very clear. There is nothing I can do here, but the denominator is not in descending order, and it has a negative leading coefficient. So first I will rearrange it, and then I will factor out what? That's our strategy. We have to stick with the strategy, please. What will I
Factor
factor?
out the negative.
Very good. And we have to make sure that we put the correct quantity inside. What should I put in here? So that this times this is this times the second term is this.
X minus 9.
Excellent. Do not simplify before we state restrictions. Or restriction. What is the value that x cannot equal?
9.
Exactly. Only after I stated the restriction, now I can simplify the whole factor. Please write 1. Please write 1. Because if you don't write 1, you may think it's 0. I'm dividing x minus 9 by itself and I get 1. I'm dividing x minus 9 by itself and I get 1. So I have a 1 at the top, I have a 1 at the bottom, and a minus in front. So what will be the final simplified form of this expression?
Negative 1.
Negative 1. However, the correct answer is this. Only if this is the correct answer. The answer is negative 1 only under the condition that x is never, ever, ever 9. So again, in this expression, if you want me to evaluate it for 5, I'll give you a number back. If you want me to evaluate it for 10, I'll give you a number back. But if you want me to evaluate it for 9, I will not be able to give you a number back. I'll say, sorry, I don't have a number for you. So therefore, all this simplifies to -1, only if x is never, ever, ever 9. If it is 9, it doesn't simplify to anything. The expression doesn't exist. Good. Moving on. Here's the next one. 6x plus 24 over x squared minus 16. They're asking us to simplify this. Get the simplified form, of course, including the restrictions. Your book doesn't do that. That's wrong. I want you to understand that the restrictions are key. Good. So what will you do first? You will simplify x with x and 24 with 16 and whatever? The answer is absolutely not. We can only simplify factors. That's why we studied factoring. So, what will I do? Please, anybody? Let's start with the top. What will you do to the top? Anyone can explain what will you do to the top? Is there something we can do to the numerator? Yes, no? 6x plus 24, any suggestions, please? This is what the test is on today, right?
Would that be 6 parentheses?
Indeed.
X plus 4?
X plus 4, indeed, perfect. Now let's look at the denominator. Thank you, perfect. Now the denominator, please.
That'll be x minus 4, x plus 4.
Excellent. Thank you very much, Samia. Good. We have to state restrictions before we move on. We cannot touch anything before we state restrictions. What are the restrictions on the variable in this case?
4.
4 and
-4?
yes. Now I can simplify, and I will only simplify the common factors, one from the top with one from the denominator. Can anyone give us the simplified form? And it has to include the restriction or restrictions. What is the simplified form here? Can anyone give us the simplified form, please?
6 over x minus 4.
6 over x minus 4, assuming that x will never be plus or minus 4. Excellent. The next one. X squared minus 5x minus 14. Good, let's work on this, please. There is nothing you can do to the top, but there is a lot you can do to the denominator. So x plus 2 is x plus 2. But can anyone give us the factor form in the denominator, please? And this is what the test is all about.
X minus 7, x plus 2.
Very good. X minus 7, x plus 2. At this point, on the raw, before we simplify, we must state restrictions, not after we simplify. After we simplify, it's too late.
7 and -2.
And now we simplify the factor from the top by itself and the factor a same identical factor from the bottom, and then we get the answer. Can anyone give us the final simplified form?
Is it 1 over x minus 7?
That's it. 1 over x minus 7, assuming these conditions are fulfilled. Next one. Y squared minus 5y plus 4. Everything y squared minus y minus 12. After this example, we'll learn how to multiply and how to divide rational expressions. So let's work on this example.